Hi there. Today we're going to talk about personal probability. Finally, something very personal, something subjective. Personal probabilities. But in order not to frighten anyone, we'll start off with something that you'll have absolutely no problem with whatsoever, guaranteed. And that is degree of belief. Degree of belief. By degree of belief, I mean how strongly we believe an event will happen, expressed as a percent, or a fraction or a decimal if you prefer. How strongly we believe something will happen, and expressed as a percent, a fraction, or a decimal. Example, let's say I'm 75% sure, or 3/4 sure, 75. Usually we talk in percent. I'm 75% sure that Tech will win the game. Tech's playing UVA tonight. I'm 75% sure they will win. That's my degree of belief. I kind of believe they're going to win. I have this feeling they're going to win, and I'm 75% sure. Well, no problem. Everyone has a degree of belief. In fact, everybody has a degree of belief about everything. If I'm building a new house, how do I feel about the contractor? Do I think he's going to do a job that I will find acceptable? What's my degree of belief in this contractor? Well, I wouldn't have hired him if I didn't have a fair, good degree of belief. And I've checked out other houses he's done, and I'm about 95% sure that I'm going to be satisfied with what he's doing. Okay? If I were only 40% sure, I wouldn't have hired him. That'd be absurd. So everybody has a degree of belief about anything. And usually we present it in a percent or a fraction or a decimal. They're equivalent, you know. But now that we all can express our degree of belief about most anything, let me tell you what a personal probability is. A personal probability is a percent or fraction or decimal which represents to us the probability that an event will happen. Well, what do you mean by that? Simply, I mean your degree of belief. Your personal probability is your degree of belief. How much do you believe this will happen? What's your percentage for this happening? Well, if I think it's going to happen, the percentage is above 50. If I think it's going to happen 75% chance, then the percentage is 75. My degree of belief is 75. And my personal probability is 75, or 0.75, if you want to make it a... Usually we talk probability in terms of fractions, so it would be 0.75. But personal probability is nothing more than your degree of belief. It's a personal, subjective thing. And we use personal probabilities just like people use real probabilities. Why are these personal? Why have real probabilities? Why not just use personal probabilities? Well, it would be pretty silly if I were flipping a coin with you. We're flipping a game. I look at the coin. It's fair coin, and we're flipping, playing, call it heads or tails or something. And I were to believe that it were a two-headed coin, or I would behave kind of silly. I would say, hey, I'll tell you what, I'll give you 10-to-1 odds. You pick tails. If it were a two-headed coin, I'd be happy to give you 10-to-1 odds if you'll constantly pick tails. Let's play the game. You pick tails, and I'll give you 10-to-1 if you ever get a tail. If I believed it was high probability of ones, I'd give you some real good advantage in the betting. It would be pretty silly if there was a fair coin, and I were to give you this advantage in the betting. I'd lose my shirt. If I believed that the coin weren't 50-50, when obviously it is 50-50, I would be a pretty foolish man. What we have to do is, first, look for equally likely outcomes. If we can't find them, do an experiment to try and estimate the probability with a proportion. If we can't do that because Tech's only going to play UVA once, and even if they play them twice or 3 times, that's certainly not a long run enough to get a probability. Well, so I have to sit back and say, well, look, I can't get equally likely outcomes. I certainly can't say, well, we have so many players and they have so many players, and therefore, and that doesn't make sense. Players aren't equally skilled. We can't take a long run frequency because Tech and UVA just can't play each other the same way. Even if they were to play over and over again, they would learn, and things would change from game to game. So it's ridiculous to think of getting an equally likely kind of probability or a frequency kind of probability. And yet I need probabilities to do things with. So I say to myself, okay, let's imagine Tech playing UVA many, many, many times. And after they play the game, their imagination, they forget they forget everything that they learned in that game, and they're right at the beginning of the game again, and they have the strength they had before, and they're all ready to play again. They play another game. And then they forget what they've learned, and they go back to where they were before the game, and they play another game. And they do this millions of times. What proportion of the time do you think Tech would win? And that's your degree of belief. That's your personal probability. That's how you get your degree of belief. But it's not something which can match up with any other probability. And the key is that if there was another probability, then you should believe in it. If you had equally likely outcomes, you should believe that there's a 50% chance the coin will be heads and 50% it's tails, because you'll lose your shirt if your degree of belief doesn't match up with the true probability. But in situations where there is no way to get at a true probability, you just put your opinion in there, and that's the best you can do. And of course, different people will have different opinions. That's why it's called personal. It's a personal probability. Okay, we're going to spend our time now working in a thing called odds. If we're going to become gamblers or understand other people who gamble, we should know what the meaning of odds. And we're going to talk about things like odds on, odds for, odds against, and any other terms that you want. If you're used to hearing other terms, you think of them. But in general, what happens with these things is that there are really two kinds of odds, either favorable, or not favorable. There's two words. The against is an unfavorable word. For is favorable. On is favorable. And as we'll see, there's really only two categories of odds. And one is pro and the other one is con. And lots of words are used. These are the most common words, and we'll spend our time with them. But if someone else uses some other kind of language, that's okay too, because there really is only two kinds. Let's talk about the odds on an event. Imagine a situation repeated several times. How many times would the event occur? That is, Tech win the game. And how many times would it not occur? That is, lose the game. So S is the number of successes, and F is the number of failures. The number of times Tech would win, the number of times Tech would lose. If I flip a coin 10 times, how many times would I get heads? How many times would I get tails? If tails was the event, heads was the event I was interested in finding the probability of. So, well, actually odds. We're not talking probability yet. We're talking odds. They're not the same. Odds is not probability. We're talking odds. Okay, occur, S, not occur, F. So we have play 11 games, 6 wins, 5 losses. Okay, the odds on an event, if this is the situation, if they played total number of games S plus F and won S and lost F, the odds on the event would be S to F. So if you'd say in 11 games they win 6 and lose 5, the odds would be 6 to 5. The odds on Tech winning would be 6 to 5. That's odds on. Odds on are S, the number S to the number F. Now how about odds? Well, we got odds on. How about odds for? Odds for are the same as odds on. They really have the same meaning. There are only two kinds of odds, and this is one of them. The kind where the success is first and the failure is second. The other kind of odds are the odds against. This is the unfavorable thing, the con kind of odds. And in this case, you put the failures first and the successes second. So if the odds on Tech were 6 to 5, that means in 11 games, I think they'd win 6 and lose 5. The odds for Tech would be 6 to 5. The odds against Tech would be 5 to 6. Okay? If the odds for are 6 to 5, then the odds against must be 5 to 6. If the odds for are S to F, the odds against are F to S. Take our example. let's say that we're considering strength of Tech and UVA. We feel that in 11 games, Tech would win 6 and lose 5. Then the odds on Tech are 6 to 5, 4. And that's another way of saying it. The odds on are 6 to 5, 4. The odds on are 5 to 6 against. See, now here getting confused. You say, oh, you said the odds on were 6 to 5, so how come the odds on are 6 to 5? Well, this word against is negating it and saying, oh, I'm talking negative here. This is the contrary. This is the opposite. I'm being contrary, so this is the odds against. So although it says odds on in this language, it means the odds against. The odds against is 6 to 5. So no matter how the wording is done, you have to decide whether they're talking about something that's against or something that's for. And if it's for, it's S to F. And if it's against, it's F to S. Simple? No real problem there. Note, we usually report odds so that the larger number is first. Thus, in the example, we would say that the odds are 6 to 5 for Tech. We would not say the odds are 5 to 6 against Tech. However, a UVA fan would say the odds are 6 to 5 against UVA. That's what they'd say. The reason they'd say that? Simple. Against is losses, successes. UVA would lose 6 times and win 5 times. If Tech is going to win 6 and lose 5, then UVA will win 5 and lose 6. And if they were to say the odds on UVA, they would have to say 5 to 6. Their wins to their losses. And that's not the right way to say it. You say it with the bigger number first, usually. It's not absolutely required, but that's usually the way it's done. And that's why you have this against and this for business, because you would like the odds to be bigger number first. So in this case, if you're a UVA fan and you believe Tech would win 6 out of 5 games, you would say the odds are 6 to 5 against UVA, or the odds against UVA are 6 to 5. Now let's learn the relation between odds and probability and degree of belief. Between these two, no problem. They're the same. So these two are absolutely the same. Now we have to find the relation between odds and the rest of them. There is obviously a relation. They are not the same thing. Let's take an example. Let's say the probability of an event happening, Tech winning, say, is 6/11. What that means, that is in 11 games, Tech would win 6 times. That is, A, whatever it is, should occur 6 times and not occur 5 times, because the total number is 11. The total number of times the thing has tried to happen is 11, 6 of which have been successful. So A has occurred 6 times and not occurred 5 times. Thus the odds are 6 to 5, 4. Look, if the probability is 6/11, the odds are 6 to 5, 4. If the odds were 5/11, the odds would be 6 to 5 against. Right? 5/11 would mean 5 wins, 6 losses. 6 losses, 5 wins. 6 losses, 5 wins against. So what is the relation? If the probability of an event is x over y, just a fraction, x over y, 5, 6/11, say, then the odds for A are x to y minus x. Y being the total number of games played, y minus x being the number of losses. This is the number of wins. So the odds on, or the odds for, are x to y minus x, the wins to the losses. The odds against are y minus x to x. And the one you use is the one with the bigger number in the front. If the odds are r to s, 4, odds on something, r to s, 4, then, in fact, when they say nothing, they just say the odds are 6 to 5, that usually means 6 to 5, 4. right? So if the odds are 6 to 5, or R to S, then the probability says I'm going to win 6 and lose 5, which means I played a total of R plus S games. That means the probability of A is the number of wins over the total number of plays. So to get probability of something from the odds, you simply take the odds for the plus, the successes, and divide by the R and S. Okay? You could, maybe if we want to stick with what we had before, and you want to say S to F, then you say the probability of A is, whoops, I'm going to have to go up to get out of the, probability of A is S over S plus F, using the notation we had before. Okay? But this is fine. The odds against, if the odds against are R to S, that means S really belongs on the top, and the probability is S over R plus S. If the odds against, and this is the number of wins, and this is the number of losses, then the probability is the number of wins divided by the total number of plays. So it's S over R plus S. So if I have the odds, I can get the probability. If I have the probability, I can get the odds. There is a relation between probability and odds. They are not the same thing. Many people think that odds are probability. So what's the probability? And then they give the odds. But the odds are not the probability. There's a slight difference. We're going to see a problem that it causes. Let's look some more. This next example will make life easy for you when you think in terms of wins and losses. The probability of something happening, of Tech winning, is the number of wins over the total number of games played. And the odds for are the wins to the losses, and the odds against are the losses to the wins. And that's all there is to it. So if you think in terms of wins and losses in games, you think of them playing so many games, 11 games, say, 6 are wins and 5 are losses. The odds for are 6 to 5. The odds against are 5 to 6. The probability of winning is 6 over 11. All right. Let's take an example to confuse you a little bit. If the odds against a long shot, and here's another way of saying against. I don't even have to say. All I have to say is it's a long shot. A long shot means the odds are against. A long shot means the probability of it happening is very small. So if the odds on a long shot, you can say the odds on a long shot are 20 to 1, no matter how they say it, it always means that this is the losses to the wins. Always the losses to the wins for a long shot. The big number is always the losses in a long shot. By definition, so no matter what they say, no matter what wording they use, once you see the word long shot, disregard their wording. They may be misspeaking. It always means the probability is very small. So if the odds are 20 to 1, you hear 20 to 1, then that means you feel that in 21 games, the horse would win only 1 out of the 21. And the probability of winning is 1/21th. Not 1/20th. See? Not 1/20th. There's not a 5% chance of winning. 20 to 1 long shot. It does not have a 5% chance of winning. It is less than a 5% chance of winning. He's a 20 to 1 long shot. He has a 1/21th chance of winning. And I want to hit that again because this occurs frequently. Let's say you feel that the horse has a 5% chance of winning. Something has a 5% chance of being correct. Then you say the odds against them are not 20 to 1, but 19 to 1. See? 5% is 1/20th of the whole. But when you're talking odds, 1/20th becomes 19 to 1, not 20 to 1. So a 20 to 1 long shot is not a 5% chance of winning. A 19 to 1 long shot has a 5% chance of winning. Okay? Nice. Confusing, but just remember that a 20 to 1 long shot has less than a 5%, and a 19 to 1 long shot has a 5%. However, most of us, when we think in terms of 5% and want to just tell someone in the street the chances, we want to say it's a long shot, we say, oh, it's 20 to 1. When we think of 5%. And that's all right if it's a casual thing and we're doing it. I have no objection, and no one should. But if we're doing it like on an exam. We want things to be a little more precise, and 19 to 1 is not the same as 20 to 1. Okay, let's go on. Let's talk about expectation. Let's talk about the expectation in a game. Say the odds for winning, the odds on, are 6 to 5. We think Tech has a 6 to 5 odds. That means the probability, we feel, our personal probability, is that there's a 6/11th chance that Tech will win and a 5/11th chance that Tech will lose. And if those are the probability, we bet $1 to play the game, and we get $1 back. If we win, if we lose, we pay $1. We win, we get $1. Okay, let's play like that. What are our expected winnings for the game? Well, if Tech wins with probability 6/11ths, we'll win $1. X, P of X, $1 times 6/11ths. We'll lose $1, minus $1 times P of X, 5/11ths. This gives us plus 1/11th dollar gain. I don't really care what that is in pennies. It's just a few cents, like a little less than 10 cents, maybe 9 cents or so. The point is, it's positive. It's a net gain. This is a net gain. So we play this game, we expect to win. We expect a net gain. We say we expect to win. That doesn't really mean we're going to win this game. It means we expect to win. That means our expectation is positive. When someone says we expect to win, that means the expectation for that game is positive. Well, let's talk about another kind of game. Let's say the odds against Tech were 6 to 5. We thought they were going to lose. So we think they're going to win with a chance of 5/11ths, and they're going to lose with a chance of 6/11ths. Okay? Let's imagine that to be the case. And we bet $1, we get $1 if we win, pay $1 if we lose. The expected winnings in this game is, well, I get $1 with probability 5/11ths, but I lose $1 with probability 6/11ths. That's about 9 cents loss. It's a net loss. I expect to lose. Play this game, you can expect to lose. That doesn't mean you're going to lose. That doesn't mean your team is going to lose. It means you can expect to lose. That expectation is negative. You expect to lose. Oh, that's interesting. We can easily figure it out. So now I want to define a fair bet. A fair bet is when the expectation is 0. Okay? That's a fair bet. When you don't expect to win or lose, you're playing a fair game. If you expect to lose, it's not fair. It's against you. If you expect to win, it's in your favor, not fair. But if the expectation is 0, it's a fair game. Let's say the odds against were 6 to 5. That means the probability of winning is 5/11ths, and the probability of losing is 6/11ths. Tech is the underdog. Okay? Tech's the underdog in this game. Now, since Tech's the underdog, when you go to the bookie, you're going to get back more than you pay in. If Tech wins, you get back more than you lose if Tech loses. So let's say we bet $5 for, that is, we put $5 on Tech. And if Tech loses, we pay $5. But if Tech wins, we get $6 back. Well, that's nice. We get back more than we lose. Well, we should, because we really don't think Tech's winning. Since we think Tech's going to lose, we want a little extra inducement to play the game. Otherwise, we're not going to play it. Why should we play even money when we think we're going to lose? Okay, what is our expected winnings for this game? We win $6 with probability 5/11ths. We lose $5 with probability 6/11ths. 0. This is a fair bet. It's a fair bet if we pay an amount and receive an amount which balances the chances of winning and losing. It's a fair bet if the expectation is 0. Expectation is 0, and we play, it's a gamble. In the game, flip a coin. Flip a coin, call it heads or tails. That's a fair game because each person has an equal opportunity to win or lose $1. Or a penny, depending on how much you're playing for. But when it's unbalanced, it's not fair to play that game. A game is fair only if each person has an equal opportunity of winning. Well then, why play? Well, Why play? Well, because I like to gamble. That's why I play. I play because I like to gamble. Not me personally, but this is the response you'll get when people say it. But that's not really why. Oh, it could be. They might like to gamble. That might be quite true, but that's not why they're betting in a game like a football game or a basketball game. They're betting because they expect to win. And here's what's going on. Let's do it slowly. Why do people bet? Let's say Mr. A believes that the odds for winning are 6 to 5. Okay, Tech has a 6 to 5 chance. Okay, that means he thinks the chances of Tech's winning are 6/11 and the chances of losing are 5/11. And let's say he plays an even game. $1 if Tech wins, lose $1 if Tech loses. His expected winnings, we've been this, is around 9 cents, or it's a net game. He expects to win. Mr. A would play that game. Mr. A would be happy to play that game because he expects to win. Now, that doesn't mean he knows Tech's going to win every game. He just expects to win, meaning his expectation is positive. Okay? Now, let's talk about Mr. B. Mr. B believed that the odds are 6 to 5 for Tech. No, against. The last one was 6 to 5. This one I want 6 to 5 against. Against, it does say. Okay. The odds against Tech are 6 to 5. He thinks that Tech has a 5/11 chance of winning and a 6/11 chance of losing. Okay, that's Mr. B. He don't think Tech's going to win. He thinks Tech has a more of a chance of losing than winning. And you come up with him and say, well, let's play the game. I'll give you $1 if Tech loses, get $1 if Tech wins. So Mr. B calculates his expectation. He says, gee, I'm going to win $1 with probably 6/11 when Tech loses. I win $1. And I will have to pay you $1 when Tech wins, but that's only going to be 5/11 of the time. Ooh, a net gain. Mr. B expects to win. Well, now we have a situation. Mr. A wants to play the game because he thinks he's taking advantage of Mr. B. I expect to win here. My expectation is positive. Mr. B calculates his expectation. And he comes up with a positive expectation. He says, hey, I'll play the game because I expect to win. How can it be that both Mr. A and Mr. B expect to win? It's easy. They didn't have the same probabilities. If you're playing a game with flipping, if you go to Las Vegas, you can expect to lose. There's no doubt about it. You can expect to lose. However, if you play a game of chance with a basketball or football, the probabilities are something that no one can really calculate. And so you do a personal calculation. And I think Tech has a 6/11 chance of winning. Mr. B thinks Tech has a 5/11 chance of winning. Aha! Not the same probabilities, and therefore not the same expectations. And that's why I can have a positive expectation, and he can have a positive expectation, and that's why we bet. So why do people bet? Because they expect to have a net gain. They expect to win, simply stated. They each expect to win. And that's why they play. They expect to win. Nobody plays in order to lose. They play in order to win. Okay? Let's take a couple of notes here. First of all, expectation refers to a long-run average, not to one outcome. People who bet on long shots do not expect to win each time. They expect to win on the average. That means the following. They're betting on a horse that's a long shot. They would be really more shocked than you if that horse won. They would like him to win, but they really don't expect, in the everyday sense, expect that horse to win. What they expect is that they're going to go to the horse race lots of times, and they're going to be betting on long shots frequently. They expect that over the long haul, more often than they should, the long shots will come in, and their net gain will be positive over the long haul of betting on these long shots. So they don't expect that particular long shot to win. They expect the average of winnings over the long haul to be positive. Okay? So when you say, I expect to win, it doesn't mean you expect to win today. It means I expect to win, meaning over the long haul, if I keep doing this kind of thing, I will get ahead. I will be ahead by the end. By the time I die, I'll be a wealthy man. By tomorrow, I may be poor, but if I keep at it, I'll be a wealthy man. Okay? Now, one more statement I'd like to make is when equally likely outcomes and repeated experiments are not available, when they are available, use them. When they're not available, we can use personal probabilities. However, the results are personal and may vary from person to person. That's what makes horse racing. The fact that everybody has a different personal probability, different opinion, and everything is fine. Okay? Personal probabilities are personal things. Do not override real probabilities, probabilities that you can calculate or figure out or obtain in other methods. Don't override them with your personal feelings. But when they're not available, you must have a personal feeling. And you get as much information as you can, and you look at it and you say, okay, I think the probability is such and such. The guy who gets closer to the real probability will do better in the long run. Okay? Have a good day.